Hi all, for my project I plan to create a evaluate command line utility which takes in equations and then solves them. So it has several options. You can write the output of whatever the evaluation was to a file. You can read the evaluation, what you want to evaluate into a file from a file, and you can also take what you want to evaluate from the command line as a parameter. And if none of these are specified, if there's no -t or -f, it'll just read from the input stream, so system.in. And typically it'll output whatever the output is to system.out, which will be overridden if you do -w, which will write it instead to a file path. So because I can't do every single operator, I'm only going to be doing addition, subtraction, multiplication, and division. And then I'm also going to be doing negation, so I have unary and binary operators over here. Additionally, I'll be having x equals y, but that'll be handled by a different portion, so that's not really an operator by the way my program defines it. So equations can be inputted in several different ways. You can have just an expression, so 1 plus 2, you can have an expression 1 plus 2 equals blank, and that'll become expression equals whatever the evaluated expression is. You can also compare two expressions, and then that'll tell you if the expressions are either equivalent is true, or if they're non-equivalent is false, or you just can't evaluate it, which means it's unsolvable. We have an unsolvable portion just because sometimes, you can't divide by 0, so that means you can't really solve it. So here's a quick little example of how the program will work. So in this case, I have my equation.txt. It's just a file. Assume this is in the command line directory. And this contains two equations down here. And then here are some commands I can enter in the command line. So evaluate-v will show version info and other info about the program. Evaluate-t will take this equation over here, or this is technically an expression, and then evaluate it. And then we can do the same thing for 18 over 36 over 2, and that's going to say, oh, yes, this is true because 36 over 2 is 18. We can also do evaluate-t, 18 equals what? 18 is 18. Evaluate, and we can take the text from my equation.txt via the command line. Since we didn't give this any arguments, this will read from the input stream, and we're just taking the data, my equation.txt, via the symbol in the command line and putting it into the input stream. We can also do the same thing using the -f, whatever the file path is, and then that'll output it back on the output stream. And we can do the same thing using -f, my equation.txt, but then we can output it back into the same file. So that'll essentially overwrite what the stuff is in the file, and the file will become this, which is completely solved. So let's take a look at the UML diagram for this project. For this project, I'm going to have an evaluate class, which will handle the command line utility, has the public static void main, and will do most of the handling for the user interface. This aggregates the equation class, which stores the text of each individual equation, and also aggregates the expression class, which stores each individual expression inside the equation. So the reason why I did this is because we can have multiple equations in one evaluate call, and we can have multiple expressions for each equation. So this just makes things easier, and they also have plenty of utilities for what we'll need. For example, you can evaluate an expression, you can solve an equation, and solve will return a string because it's going to become a string, not an actual value. But an expression will evaluate to a numeric value. And I say numeric because we can have integers and doubles, since it's better to do addition and subtraction of integers, and if someone enters a double, we also need to be able to handle that too. So a little bit of polymorphism in there to handle that. Case. So when we actually store expressions, we have a abstract class operator, which in turn is extended by a unary operator and a binary operator. So unary operator is just one single operand, While in binary operators, 2 operands. So an example of a unary operator, which is the one I'm using, is negate, and binary operators are add, subtract, multiply, and divide. And the operator class has a method called evaluate. So all you have to do is you have to call evaluate, and each individual operator will have information based off of the operands stored as objects, because operands can be expressions, they can be operators, they can be numeric values. So in this case, a unary operator will solve based on what kind of class it is and what kind of operator it has. And when you hit evaluate, it'll return a numeric value of the evaluation, and you can keep on bringing that back, so you can essentially just do recursive solving with these guys. So how will this actually look? So we start with a text string that we input, and then that becomes this, then the text just goes right into an equation, since we only have one equation right here. Then we split up the equation into 2 separate expressions. Since we have 2 expressions in this equation, we have 1 times 2 over 1 plus 5 equals 5 and 5. And then we split these up into 2 different expressions. These are just sub-expressions to just to break it down, because we have a parentheses right here and we have to worry about order of operations. So we split this into 1 times 2 and 1 plus 5. 1 plus 5 becomes an operator of 1 and 5, which are both numeric values. And then we have an expression of 1 times 2, which becomes an operator, and we take divide 2, comma, whatever this expression is. So this points to this expression. And then we have divide 2, comma, add 1, comma, 5, since that's the operator inside this expression. And then we multiply it all by 1, since we have the 1 in front, which I guess I could probably skip, but too many cases. So all in all, that's how my program will work, and thank you for listening. Bye.